So the next thing I want to cover in my basic HAL tutorial is the net command. Now the net command is very important with HAL because net is what connects the physical world to the virtual world. And what I mean by that is it connects your physical hardware to your virtual hardware. Think of it as a circuit board. You have wires coming off of your stepper motor drive that plug into the step and direction ports on your breakout board. HAL is essentially doing the same thing. You're taking the breakout board pins and you're connecting those to the step and direction input of LinuxCNC. Now, a lot of the stepper and a lot of the spindle control, that's all handled by the wizards. There's going to be a lot of times where you're going to need to know your net commands in order to do things that are out of the box. But if we go into, this time we'll do PNCconf wizard. In the PNCconf wizard, if we click on the Show Advanced Option page, and we just go through and we start creating a new machine, eventually we get to a page called External Controls. Now the External Controls allows you to set up a VFD. It allows you to set up external button jogging. It allows you to set up an MPG. It allows you to set up a feed override, max velocity override, spindle override, and then USB jog. The USB jogging one is the one that I use primarily to set up PlayStation controllers as control pendants. To do that, the first thing we want to do is go to Add Device Rule. And it'll say a general rule already exists, but please disconnect your USB device. I'll say yes. It'll say plug in USB device. So I'll plug in my controller. I'll say yes. And it's going to come up with the driver information, and it's going to add the rule. When I say yes, I have to put in my password so it can go through and activate the driver. It'll say please unplug and plug in your device again, so I'll do that. I'll hit OK. From there, I now have an established device. The device name comes up as USB. If I go to test device, I'll get a series of pins inside of Halmeter. Now, Halmeter is something that you can use to test your devices, your signals, you can check parameters. But the pin section, if I go down to input.0.abs-hat, 0x is positive, and click on that, in Halmeter, right now I have a false reading. If I press the button for X positive on my controller, which is the X positive directional controller, or the directional pad, you'll see that it goes from false to true. Now this is what this input.0.abs-hat 0x is positive is what we will use to connect the physical hardware to LinuxCNC. And we'll go through and we'll find all of the buttons that correspond with what we're trying to accomplish by means of the Halmeter. This gets a little cumbersome. There is a slightly, I wouldn't say better way, but there is a quicker way. There's a more clear way of doing it. And the way of doing that is to just put in one hat OX is pause. I believe that was a dot. Just put in 1, that way you get the basic breakdown of what you're trying to achieve. I'm not going to go through the entire thing, but if you go through and you put in for your X positive, Y positive, X negative, Y negative, you'll get basically what you see on the right hand side here. You'll get the HAL UI signals that get put into your HAL file via the PNCconf wizard, and then underneath there you'll get the USB device jog button signals that get created in the case of, you'll see right here, input.0.abs-hat0x is pause for jog x pause. Now if you look up here, you'll also see a net jog x pause. This is what threw me off in the beginning because I didn't realize that this was just a breakdown of netting the exact same signal in 2 different places. If we look on the example on the left-hand side here, you'll see that you have net signal name and then pin name. You have an optional arrow that you can put in to tell whether it's an input, an output, or an I/O. And then after that, you have an optional second pin that you can put in. Now that, it doesn't really explain much in the HAL tutorial, only to say that underneath it says net home x axis.0.home -sw-in with a directional arrow coming from parport.0.pin-11-in. Okay, so now anybody that looks at this that has just installed LinuxCNC is going to look at it with big bright eyeballs, and they're going to stare it down for about 5 minutes and say, what the hell is this? They're going to close the computer down, they're going to reinstall Windows, and they're going to buy Mach 3. Don't be afraid of what you see here. And don't be afraid of what you see here. All this is saying is that we're going to connect something to a signal that just has an arbitrary name. Jog-x-pause is just a name given by the PNCconf wizard. It doesn't care if it's jog-x-pause or if it's fill-x-what. The only thing it cares about is that it has a name, it has a pin that it's connected to. In this case, it's halui.axis.x.plus. Now that's something that has meaning, that has substance. That means something to LinuxCNC. Just like down here, this net jog-x-pause, if I change that to fill-x-what, that is telling this net line that it's connected to this net line, and that the HAL UI signal is connected to the physical input.0.abs-hat0x is pause. And that was the signal for the directional pad for pressing to the right. So if I save that and I open my rant mill, which that custom post GUI HAL is part of, I'll home this out real quick. Now, if I go into HAL show, now this is where I said it's not easier, it's just a little clearer. HAL show or HAL configuration will give me a breakdown of all of the HAL components and available pins that I can use in my HAL file. And if I go under input 0, here we'll see, hey look, there's that ABS-hat 0x is pos. Inside of this show window, we're going to see that it's connected to fill-x-what. And that's what we put into the custom post GUI HAL. If I go to my watch list, this is a very powerful tool, because when you have inputs and outputs and you want to monitor the status of whether they are true or false, you can add a list of pins to your watch list and you can see what those pins are doing. So if I go to the ABS-hat 0x is pos, right now we see a little dark light or dark LED. If I press the right button on my PlayStation controller, you're going to see that it goes true and it lights up in a bright yellow. So this value here, this input.0.abs-hat 0x is pos, is the physical input that I'm tying to the virtual input inside of LinuxCNC, which is the HAL UI. If we look at HAL UI, and I go back up, so HAL UI, here, HAL UI dot axis dot x dot plus. So we go to HAL UI, axis, x, plus. Add that to the watch list. And when I press the right hand button on my directional pad, you'll see that both of them light up. The reason that both of them light up is because they're both tied together. They're connected virtually from the physical world to the LinuxCNC environment. So that's why net is important, because you can use net to connect all kinds of inputs and outputs from physical to virtual. And by physical, I don't always mean physical as in I'm holding a button in the palm of my hand. It just means some sort of user interactive interface. So that could mean a physical button that I'm holding in my hand, or it could be a button that I created in PyVCP or Glade VCP or something like that. So whenever you press a button inside of LinuxCNC, each of these little buttons have their own tiebacks to HAL. Even though they are GUI-based buttons, they're still considered physical hardware, so to speak. That being said, to eliminate some confusion, if you don't like the way that the breakdown is given with the net signals being connected here and then the physical signals being connected here, all you'd have to do is copy that, get rid of this, scroll up, and then next to the fill-what, just paste that input.0.abs-hat is pos. And that input.0.abs pos is connecting to LinuxCNC HAL axis.x.plus. And the second that it connected in my head was the second that I basically found a new enjoyment for using LinuxCNC. Because once this clicked, I was able to do a world of things that were not possible prior to knowing how to do this. So again, follow the basic and advanced HAL tutorials, because they'll walk you through a good majority of what you are looking to accomplish in the world of HAL. Some things click a little bit quicker than others, and believe me, I'm there with you. It was an uphill battle until I realized that all I'm doing is I'm standing there with my soldering iron, a piece of wire in my hand, a switch, and something to connect the switch to. And I'm just soldering the switch to that thing by means of this net command. Once you have your basic Linux CNC environment built in your wizard, become familiar with the HAL configuration. In gmocapy, it's called HAL show. In Axis, it should just be called configuration. So I'll open that up real quick and we will find out. Okay. So under machine, yep, it's under show HAL configuration. But once you have a basic machine setup, you can open the HAL configuration. You can see the available pins for each of the components that get loaded. You can see parameters for a lot of the I/O that you would have. You can see the signals. Now the signals are what get created when you do a net command. So if I open that rant mill back up, I just want to show you that when I open up my HAL configuration, remember we called that one net command fill x what. We could see in the pin section under input 0 ABS hat is pause, fill x what. But if I scroll down to the signal section, look what we have here. Fill x what. Fill x what also tells me that the input.0.abs hat is pause is connected to HAL UI.axis.x.plus. So this HAL configuration window is a very, very powerful and very, very necessary tool to kind of wrap your head around what is happening when you net a pin to a name to a signal. So the last thing I want to cover is you're probably wondering where I got that custom PostGUI HAL file from. So now when you go in to your wizard and you create your machine configuration, you get a folder for that particular configuration that's located under your home folder, LinuxCNC configs. So you'll see right here I have a whole slew of different folders for all of the machine configurations that I've created. So under rant mill, you'll see right here I have a whole bunch of files. Now these files get created automatically when I run a configuration wizard. So here I have my rantmill.hal, and I've got all of the major components that tie into one another for my step gens and for my e-stop control and things like that. The main HAL file is something that gets overwritten when you rerun those wizards. So what you'll want to do is you'll want to get into a habit of making your HAL changes as in either a backup of your main HAL or do it in your custom PostGUI HAL. There's times where the custom PostGUI HAL won't like some of the input because it's supposed to run before the interface pops up, but I haven't had any I haven't had any issues with even the classic ladder stuff. I haven't had any issues with putting that into my custom post GUI HAL and letting it run after the GUI starts up. If I have an error, that pops up, it doesn't pop up because it's in the custom post GUI HAL. It's because I fat fingered something and it wasn't right. So the last thing I want to cover is if you make a change to your HAL file and you do screw up, when you go to load LinuxCNC, you're going to get an error message, and then at the very bottom under the debug file information, you'll see right here, clear as day, servo-3 not found. That just means that I messed up in my rantmill HAL file, and I just need to add a D. So it shows you pretty clearly what you did wrong or what it's looking for to be right. And you see, I make that one change, the machine fires back up. So I'm trying to keep these videos around 20-ish or so minutes, so I'm going to end this one, and we will pick back up in part 3 with the set S, set P, and unlink P commands within the HAL configuration, and that should pretty much get you through the bare bones basics of what you're going to need to make changes in your HAL file. And again, if you want to learn more about AND, OR, or XOR, please look at my classic ladder video for AND, OR, and XOR. Those examples are pretty much what you're going to need to create AND, OR, and XOR within your HAL file, and it'll help you decide whether you want to do it in HAL or if you want to do it in classic ladder. So thanks again for watching. Please be sure to like and subscribe, and stay tuned for more tutorials. See you soon.